Hello, my little mathematicians. Today we're going to go through all the different types of one-step equations that we can solve. But before we do that, we're going to review how do you determine whether the given value is a solution of the equation. So to determine if it's a solution, you're basically just checking to see if what they think the answer is correct. So I replace what they think the answer is into my original equation. So let's replace the x with an 8 plus 7 equals 15 and see if it makes a true statement. 8 plus 7 is 15. Bring down your equals 15. Is that a true statement? Yes, it is. So then, yes, 8 would be the correct answer. Okay, substitute in what they think it is. It's 5 minus 4 equals 9 according to them. And 5 minus 4 is 1. Bring down your equals 9. That is not a true statement, so no. 5 was not the solution. Okay, for this one, 6 times they think x is 7 equals 44. Well, 6 times 7 is 42 equals 44. And no, that is not a true statement. So no, 7 was not the solution. Okay, here, you're going to replace x with 18 divided by 3 equals 6. 18 divided by 3 is 6. And that is a true statement. So then, yes, 18 was indeed the correct answer. All right. Now let's review how to solve addition equations. Let's first draw a line down from my equal sign. And you want to isolate your variable, and you do that by using the subtraction property of equality, meaning that you can subtract both sides of an equation by the same number, and the two sides will stay equal. So as long as you do one thing to one side and you do it to the other, you can do whatever you want. Okay, so if I can subtract something on one side, as long as you subtract it to the other, you can subtract whatever you want. And I'm going to subtract 11 because I want x to get by itself. And 11 minus 11 is 0. And now you just have x on this side, which is what I wanted. I wanted to isolate the variable. So since we subtracted 11 here, let's subtract it on the right as well. And 17 minus 11 is 6. That's my final answer. You always want to double check. X plus 11 equals 17. And I think x is 6. 6 plus 11 is 17. 17 equals 17 is a true statement. So yes, 6 was indeed the correct answer. And put some bigger numbers and some smaller numbers. Okay, my next one. Draw a line down from your equal sign. And remember, you can always pause the video, try it yourself, and then unpause it and join us again. Okay, to get x by itself, you want to do the inverse of adding, which is to subtract. And whatever you do to one side, do to the other, according to the subtraction property of equality. So now those cancel, because 4 minus 4 is 0. Bring down your x equals, and 9 minus 4 is 5. So I think it's 5, but before I boldly bubble that in, let's check. X plus 4 equals 9. I think x is 5. 5 plus 4 is 9. True statement. So yes, 5 was indeed the correct answer. All right, and finally, okay, this time x is over here. So to get x by itself, I need to get rid of this plus 12. The inverse of adding 12 is to subtract 12. Whatever you do to one side, you have to do to the other. Now those cancel, and you have x equals 21 minus 12. Well, I need to borrow. 11 minus 2 is 9. 1 minus 1 is 0. So you have 9 equals x. Okay, before I for sure bubble that in, let's double check. And I think that x was 9. So 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Bring down your 21. And yes, that was a true statement. So 9 was indeed the correct answer. Pick 2 bigger and 2 smaller. And there you go, you graphed it. Okay, for my next one. Now we're going to use the addition property of equality, and that's saying that you can add both sides of the equation by the same number, and the two sides will stay equal as long as you do it to both sides. So let's draw a line down, and this time we're adding because the inverse of subtracting is to add. And we do that because 10 minus 10 is 0. They cancel. Now you just have x by itself. But whatever you do to one side, you have to do the other. 10 plus 3 is 13. Okay, and now you have x minus 10 equals 3. Let's replace the x with a 13. 13 minus 10 is 3. Bring down your equals 3. Yes, that was a true statement. So for sure, 13 was indeed the correct answer. Two numbers bigger and two numbers smaller. For my next one, draw a line down from your equals sign. Here's where your variable is. You want to get rid of this minus 19. So the inverse of that is to add 19 to both sides. Now 19 minus 19 goes away. You just have x. And on this side, 19 plus 2 is 21. So I think 21 is the answer. Let's double check. Replace your x with what you think it is. 21 minus 19 is 2. Bring down your equals 2. That is a true statement, so you know for sure that 21 was indeed the correct answer. So two numbers bigger and two numbers smaller. Okay, and let's bring down our next one. The inverse of subtracting 18 is to add 18. Whatever you do to one side, do to the other. The 18s now cancel because 18 minus 18 is 0. Now you just have x on this side. And when you combine these, you get 25. Let's go ahead and check to make sure that it's right. And I'm going to replace x with what I think it is, 25. Bring everything else down. 25 minus 18 is 7. So yes, I got a true statement. So 25 was indeed the correct answer. Now I know a lot of these you could do in your head, but we're practicing the steps for when they get harder. Okay, so yes, please be showing the inverse step and checking your answers so that then you know how to check your answers and how to do the inverse step when they get more complicated. All right, let's go ahead and turn the page. We're almost done. Okay, the next one we want to do is we're going to talk about the division property of equality. The division property of equality is that you can divide both sides of an equation by the same number, and the two sides will stay equal. I think you're seeing a pattern here, right? Okay, and the reason I'm going to divide is because here the two numbers are being multiplied, and the inverse of multiplying is to divide. So when I divide by 8, 8 divided by 8 is 1. So now you have 1 times x, which is just x. And whatever you do to one side, you have to do to the other. Now 72 divided by 8 is 9. So I think it's 9. Let's go ahead and check. 8x equals 72. 8 times, I think x is 9. 8 times 9 is 72. That is a true statement. So yes, 9 was indeed the correct answer. 2 bigger and 2 smaller for my graph. Okay, bring down a line. Let's bring down a line here. Okay, this is where my x is. To isolate it, I want to get rid of that 3 that's being multiplied, and the inverse of multiplying is to divide. Do the same thing to the other side. And 3 divided by 3 is 1. 1 times x is x. And 24 divided by 3 is 8. I think x is 8. Let's double check. And I'm going to replace my x with an 8. 3 times 8 is 24. Bring down the equals 24. That is a true statement. So yes, 8 was indeed the correct answer. So 9, 10, and 7, 6. Okay, now this time my x is on this side. So I have a 12 being multiplied by the x. The inverse of multiplying is to divide. Do the same thing to the other side. 12 divided by 12 is 1. So you have 1x, or just x. And 60 divided by 12 is 5. 5 is my answer, or so I think. Let's double check. Okay, I'm going to replace x with, I think it's 5. 12 times 5 is 60. Bring down my equals 60. Yes, that is a true statement, so 5 was the correct answer. And finally, now we're going to do the multiplication property of equality. And that's saying that you can multiply both sides of an equation by the same number, and then the two sides will remain equal. Why are we going to be multiplying? Because this time these are division equations, and the inverse of dividing is to multiply. Okay, so now these twos cancel out. Just like if, let's say I had a fraction over here of 3 and a 3, and let's make this a 7 and a 5. Okay, so both of these can be divided by 3, right? And 3 divided by 3 is 1, and these 3 divided by 3 is 1. So the two diagonally across from each other cross-canceled and just became 1, right? So essentially I'm doing the same thing here of 2 over 1, and now these both cross-canceled and became 1. You have 1 times x, or just x, and 1 on the bottom, so x over 1 is just x. So I multiplied by 2 to get that 2 to cancel out. And whatever you do to one side, you do to the other. 9 times 2 is 18. So I think 18 is the answer. Let's double check. And I'm going to replace the x with an 18. 18 divided by 2 is 9. 9 equals 9 is a true statement. So 2 numbers bigger and 2 numbers smaller. Okay, this one is saying divided by 7. So the inverse of that is to multiply by 7. Those now cross cancel and become 1. 1 times x is x. Whatever you do to one side, you got to do to the other. So 4 times 7 is 28. I think 28 is the answer, but let's just double check. I'm going to replace the x with what I think it is. 28 divided by 7 is 4. Bring down your equals 4. True statement. So yes, 28 was indeed the correct answer. Okay, if you haven't tried one yourself, pause it first. Okay, now unpause it and you're back with us. This is saying divided by 5. So the inverse is to multiply by 5. Those cancel, and 1 times x is x. This side, 5 times 9 is 45. So we think the answer is 45. If we were to go ahead and check, you have 9 equals x over 5. I think x is 45. 45 divided by 5 is 9, equals 9. True statement. So yes, 45 was indeed the correct answer. 2 numbers bigger and 2 numbers smaller. If you got all of those correct, congratulations. If not, feel free to watch it again and maybe slow it down and try it yourself. I have faith in you guys. If you got them all right, though, congratulations. You've mastered all the different operations